Welcome back, everyone, to another session of Big Data Days 2022. I am Jeremy, and I'll be the host for this session. It's my absolute pleasure to welcome our next speaker, Mr. Josep Curto Diaz. Joseph is an advisor, consultant, data scientist, entrepreneur, and professor who has helped many companies to create competitive advantages based on data and algorithms. He is also the founder of Antenna Core. He complements his professional career with a passion for higher education, being the academic director of the Master in Business Intelligence and Big Data Analytics at University of Catalonia in Spain, and also a casual lecturer at the University of New South Wales, where he gives lecture about responsible AI, data science, data governance, big data, and data-driven strategies for future managers and developers. In this talk, Joseph will speak about the problem of the absence of fairness in AI systems. The talk will be about some of the ways and tools we have today to measure and mitigate the existence of bias and ensure better decision making. So, Joseph, whenever you are ready, the floor is yours.
Thank you so much, Jeremy. It's a pleasure being with you today. The topic that I'm going to discuss is a very complex topic, but we need to start speaking because it's extremely relevant. So let me share for a moment, the content that I prepared. So I'm hoping that you already are able to see the slides, and I'm going to start speaking about this. So fairness, why we need to speak about fairness? Because we are betting on artificial intelligence. We are betting on automate our decision-making process. We want to accelerate and we want to transform our organizations. And we believe that data and algorithms are the best way to compete in the market, to create new products or services, or even to transform completely the way we operate. So that's why we need to pay attention to the potential flaws, the potential mistakes that we can make. And one of them is not taking into consideration fairness. Jeremy has already introduced me, so I'm not going to review or repeat those things. The only thing is I love to speak with companies and I love to travel to countries just to discover what they are doing. And that passion leads me to go from Europe, that is where I used to live, and then to Asia, Africa, North America, South America, everywhere. Because the best way to discover how companies operate and what they do is to speak with them directly. So let me start for a moment with some examples. What is happening right now? So those companies that they have issues with fairness, sometimes we discover that they make mistakes. For example, in the case of Facebook, they made a mistake classifying the videos. When they were classifying the videos and the content, there was a slight mistake where people that is Black was classified as private. And then what happened? That when other users of the platform, they were searching for, other videos about Black people, suddenly the recommendation was just private videos. The first thing that we think is social network is racist. But the reality, we need to analyze what is happening behind. What's happening behind is that they didn't implement any of the practices that probably you discovered in the previous keynote about responsible artificial intelligence. That will help us to understand what our algorithms are doing. So when you don't control what is happening, the first thing that happens is your algorithm goes wild and start putting you in a complex situation. It's not the only one. And you may say, okay, it's just the social media that they don't control what we generate and the way we tag, and we can confuse the algorithms. However, it's governments as well. Some governments, like for example, the United States, they have created, and they are not the only one, that happens in Europe as well. They have created systems that based on the information that they have, what they do, they decide if you go to jail or not. Can you imagine that is an algorithm that recollects your data, your personal data, what you did in the past, the data about the case, and based on historical data, they suddenly decide if you go to jail or not. Algorithms can decide our destiny. And it's not only about going to jail, which is, you can think it's the extreme case. It could be as well, when we are applying for healthcare. Let me explain one small case. Tammy Dobbs. She was living in Missouri. She was covered by Medicare, in that state. Suddenly, for many reasons, and that's quite natural in other states, she moved to another state, Arkansas. And in that state, they have a system that classifies, that decides if someone is going to be provided with a caretaker, like in her case, or not. So from having a caretaker, suddenly she was without any care, out of the system. So one more time, what happens? Both institutions, the healthcare and the government or the protection, the police, they were using a system and they were not controlling what was happening. And that could lead to unfair situations for the people that, suffers the algorithm, suffers the system, they are the users. And you may say, hey, come on, I'm not a social media company, I'm not an institution, I'm not a government. So those examples, they don't resonate with me. Anything that you implement in your company is prone to make a mistake. And even big companies, they can make mistakes. Let me explain for a moment about Amazon. The amount of people that they apply to Amazon because they want to work with them is massive. So what they did, if you have this incredible pool of talent that they want to apply to your organization, come on, you're a data-driven organization, so you're going to create an algorithm based on your previous, employees, ones that you hire, to be able to determine, which are the ones that are fit, that are the best ones for your company. You know what happened? The system had a bias towards male candidates. So by default was considered a male instead of a woman. Well, you may say, hey, maybe the males are better for this job. But this can create a lot of issues. For example, you are keeping outside a lot of talent that maybe it's the right one. You are creating just the same type of profiles all over again. So when you want to bet in a new country, or in a new industry, maybe you don't have the skills. So you are reducing your chances to compete in the market because you don't have the right talent. And this mistake is done by many companies. We are speaking about Google, we are speaking about Apple, we are speaking about many others. Fairness is a very complicated problem. So I'm going to speak about how fair or how unfair are the machine learning systems. And obviously, what happens like each one of us, we already have ingrained what is the definition of being fair or unfair. But in the context of machine learning, we need to have a proper definition. So I like this definition, from Wikipedia, and it says, what does it mean to be fair? From the algorithmic point of view, it means that the results are independent from some specific variables. Those variables that we call sensitive. Why they are sensitive? Because they contain information that could lead to have a group that have privileges against the rest. It could be gender, ethnicity, sexual orientation, disability, and many other. So as you can imagine, this is tough because they're telling us, those variables, they are not going to influence the result. Not an easy thing to add in each one of our projects if we want to take into consideration fairness. So the best way to understand the problems, let me go deeper into a specific example. So I'm going to discuss the case of ProPublica versus Compass. Maybe you don't know ProPublica. It's an organization that tries to understand how algorithms are used in society and if those algorithms are fair or not. And what is Compass? Compass is an amazing algorithm that, is the correctional offender management profiling for alternative sanctions. In other words, what does this algorithm, is doing? So for those people that are in jail, the algorithm classifies them into low risk, high risk, from 1 to 10. And this high risk will let us decide to the stakeholders, in this case, the management in the prison, if it makes sense to give, freedom, conditional freedom to those people or not. I don't know, you guys. No, if I start thinking for a moment, this is the United States. This is about people that is in jail. I can smell problems directly. So once this system was put into production, Compass, so the people in ProPublica was very worried about what was happening. But the guys that were behind ProPublica, not the company, they thought, come on, let's try to avoid issues. So they decided to take an approach. This is the information that they were collecting, risk assessment. As you can see, for each one of those persons, they were, those offenders, they took they considered the gender, the marital status, the agency behind, the charges that goes from homicide to fraud and many other things, if they use weapons, if they were sex offense and so on. As you can see, a lot of information. But they decide, because I thought race is going to be a problem, we are going to remove it. We are not going to consider. So we don't want race to be part of our analysis, because I thought we are sure that something is going to happen. I'm sure that some of you think, oh, that's a good idea, because if you remove race, the algorithm is not going to take that into consideration. Let's wait for a moment. ProPublica thought, what if we still have that problem? So what they did is, when they got access to the information and the results of the algorithm, so they bring back the race variable, and then they classify what's happened with the prisoners in the jails, how they were classified. As you can see, there's a huge difference between black and white. And white is skewed towards 1 or 2 scoring, which means that low risk, while black is quite distributed. So they thought, could it be that we have an issue here? Could it be that we have a problem? How we discover that we have a problem? For those that are already very fluent in machine learning, and what we can do with that, is it clear that this is just, a problem where we can classify, each one of our different people with this particular ranking. And they thought, okay, the best way to understand is let's try to use the tool that we consider to evaluate if the algorithm is right or wrong. In other words, it's like they try to think what we can do to understand. And the first thing that they did is let's pick a couple of examples. Let's see what happens with them. Let's see if we found a mistake, and because we found a mistake, then it makes sense to go deeper. So let me introduce Vernon and Brisha. Vernon and Brisha, one is white, one is black. Vernon was assigned this low risk 3, and Brisha was assigned this high risk 8. What we are thinking, what the algorithm is telling us, is that the algorithm is quite sure that Brisha is going to commit another offense when she is released. While what it's telling us for Vernon is that he has a very low chance to commit another crime. But let's see the data and what happened with Brisha. So Brisha just committed 4 juvenile misdemeanors, nothing. But then when she was released, there was no subsequent offenses. I'm sure that you know what happened with Vernon. Vernon, this poor guy, he already did several robberies, 2 armed, 1 attempted armed robbery. And then when he was released, the offense was a grand theft. Obviously, if you take this just to instances of the data, you discover that there is something wrong. How can it be that Vernon is low risk? How can it be that Brisha is high risk? What is wrong here? Why it's not working? And why it was put into production? So ProPublica, then they start splitting the information. They consider what we call is discovering and analyzing the type 2 and type 1 errors in the confusion matrix. This matrix that presents us how it works, if this classification system works or not. So as you can see, what happened is what it was not working is 4 black people, many of them were classified at high risk, but they didn't reoffend. And then For white people, for African American, it was labeled high risk, but they didn't reoffend. And for white, labeled lower risk, yet they did reoffend. So as you can see, there was something wrong. There is not the same type of classification. No, it's not the same way they work the algorithm, and there is a discrimination of white versus African American. And you may wonder what they did. So let me go back to the first problem that they encountered. So they thought that the removing the variable, in this case race, it's enough. So if we use this technique, which is called unawareness, it's like we ignore the variable, the majority of times it's not working. We need to be honest with that, because in reality, what happens is like there are many other elements that are already ingrained in the data. So it doesn't mean that just this removing the column, it doesn't work. So what we can do, let's research what happened. So obviously, as I told you before, we are going to use what? The confusion matrix to understand what happened. As you can see, in our case, Brescia was a false positive because obviously it was identified as high risk, but it wasn't. And Vernon was a false negative. It was identified a low risk, but it wasn't. So as you can see, we have issues regarding people that could be more innocent and we force them to be in jail again, or people that is criminal and we release them in society. And obviously all these criminal people, well, it needs to be very well done, otherwise they are outside, like me speaking right now in front of you about fairness. So what they did, or what we can do, what ProPublica did is to consider the confusion matrix and the ranges that we can create from the true positive, the false negative, and the true negative. Okay, so from the false positive rate is the numbers that we saw. What happens with the black people and the white people. And from the false negative rate, you can see the other mistake. Type 1 and type 2. In the context of fairness, when we speak about the comparison between the false positive rate and the false negative rate, we're speaking about equalized odds. We are expecting, if there is fairness, that the numbers will be the same for black and white, or for the different groups that we have. Obviously, this is what ProPublica was saying. Hey, this is not working. That is something. But what are you going to do if you are the creator of this? Well, North Point, the company behind, said, hey, look at the base rates. What are the base rates? So let me go back, because that's the funny part. It's like with these numbers, very easy to get from the algorithm when it's executed, we are able to find things. And when we speak about the base rates, we're speaking about the prevalence, the proportion of actual cases in each class. And when we compare, it's like, oh, there are more black people in the data set than white people. And then you may think it's natural that this happens. But North Point, continuing with the defense, and said, if you look to the predictive parity, then you will see there is nothing. There is no issue here. There is no discrimination at all. We are fair. What are they talking to you? They're telling you, let's use the positive predictive value, the precision. That in the context of fairness, we call it the predictive rate parity. And as you can see, if you calculate the numbers, it's 0.66 against 0.64. And that's why North Point, told the customer, it makes sense to put this system into production. Wow. Now the question is, who is right? Which metrics are correct? One or all? I'm sure that if I open the micro and said, hey, what do you think? And you will say, I don't have a clue. I do believe that North Point was, right. I do believe that ProPublica is right. Well, this is slightly more complicated because in reality, it depends. And it depends on what? It depends on your view of the world. If you believe that what you see is what you get, in other words, what you collect and what you generate with your data represents the reality, then your approach will be like North Point. This is what we have. This is what we can obtain with what we have. And there is nothing else to take into consideration. Some cases, they may be like this one. But if you are like ProPublica, then you will believe that we are all equal. So then you will take into consideration the other approach. It's like, let's think about the equalized odds and let's see what happens. So we're speaking about it's two different views of the world, two different views on how we need to implement machine learning and artificial intelligence. And obviously, these views are in conflict because the reality is there is not a single algorithm that can satisfy both at the same time. And you may say, what are you talking about? I thought that you're going to provide me with a solution. Well, what I'm going to tell you, I study math, and sometimes we need to jump into math into this. Like, we even have a chance to discover why we cannot optimize all the metrics at the same time, why they are incompatible for this optimization. Well, already there is a paper, and you can go to this paper, fair prediction with disparate impact, and you will find that the researcher discovered this formula that relates all the different ratios, and then suddenly it's like, okay, it's impossible to optimize both at the same time. So it's like when one is very good, the other one it will be very bad. So you need to choose carefully which is your view on fairness. So what we can do, what can we do something? Well, already is yes, it's very important to pay attention. It's very important to understand the context. So that means that our data scientists to understand the context, because the data scientists most of the times what we know about techniques, we know about implementing projects, we know about scaling the projects, we know about vendors, languages, and algorithms, but sometimes we are not fully 100% experts in the domain. So we need the domain experts and the stakeholders. And then we can use different metrics that will help us to understand. Inequalities is one of my first recommendations today. They have this amazing, tree where they explain you which are the metrics that we can use and which are the notions and the reasons why we use them. And you can have the fairness tree complete, or you can have a summary. And as you can see, here is like a good way, defined as a decision tree, obviously, how to choose which is the metric that is going to help me to understand the fairness in my particular problem. And in our case, ProPublica was using the FPR parity, false positive rate. So that means that obviously it is a tough job because we have many options to understand why, in our algorithm maybe is not fair. So one more time, if we go back to the context is, do we want to put a non-violent person going to jail, or we want to control that a violent person remains free? So to go back to the traditional, are you keeping at bay type 2 or type 1 errors in your model? But there is more that we can do, And there is something else I want to explain about this case before jumping to my recommendations. First is about the accuracy. What happened with the accuracy of the system? So the accuracy of Compass, it was just 0.61. Not much better than a coin toss. And between me and you, I won't be brave, to put this into production because we are speaking about the life of people, even if they commit a crime. If you believe that there is a chance to be back in society and bring back value, so then this algorithm obviously was doomed to fail. So having said that, what we can do? So two things: audit and mitigate bias. Obviously, what we want is to balance in those cases that make sense, because we have different views of what is to be fair, the biases. So I recommend, first understand one thing. You are going to make mistakes. Your algorithms can fail. And when I say they can fail, they can have errors along the whole process. If you work enough in this context, you will see that you can make mistakes in the problem statement, in the data collection labeling, data analysis and cleaning, model selection, model training, model evaluation, and even model deployment. And one of the worst things is that sometimes you only recognize the errors, the mistakes, when you put them into production. It's like we created this amazing image recognition system that detects wolves, but in reality it detects the wolves because there is snow behind, not because it's a wolf. No, so you found that at the end when you put it in production, like the case of Facebook, like the case of many of the examples that I discussed today. So what we can do, I recommend first think in terms of which are the biases that our data, our generation process, our collection process, our selection process, our model can have. And those are some of the biases, traditional biases that we can find everywhere. From the confirmation bias, you have already some preconceptions and you just want to validate them, okay? Or status quo, no, if things broke, don't fix it. So there are many things that could happen in the project, some of them related with data, some of them the way we implement the systems. So think carefully that the biases that we have as people and the biases that our system can collect, it will affect in a deep, very deep way, the results of our algorithms. And I'm not speaking that you have issues with data quality. This goes beyond, because it could be that you are collecting data that is complete, that we have all the information, but it has a bias. Think about what happened in the United States. In the United States, the police is prone to consider Black people and Latino as criminals by default, which means it's more prone that they receive a violent approach, when they are captured and so on, or even killed. That's the way the origin of the Black Lives Matters movement. So what we can do, this is my recommendation. And first, it means that we need to understand the bias, which are the origins. It could be socio-technical causes, and those socio-technical could be data generation, data collection, or even it could be institutional bias, like in the case, the by default society has this perception towards some minorities, And then we need to understand how bias manifests in data. So we need to do this data exploration. But this data exploration is not enough. What we need to do is to do the model exploration that we were showing right now, with, for example, the particular, coefficient matrix. And then, think clearly, which is the definition that we're going to use for fairness in our organization? Because, and in each one of the projects, it's not a lot about what we think as a company, but what we are implementing. Once you know that, you will know that if you have a bias, if it's something that concerns us, and if it makes sense to address the bias, and then you have three options: before, during, or after. But you need to think something very clear. When we mitigate the bias, there is a trade-off. And the trade-off is like when you change things in the values, when you change the model that you use, or when you reprocess later on, for example, the boundary decision in your algorithm, you are changing the performance of the algorithm. So it's natural that will work worse. It's natural. And then the last thing is like accountability. How we explain what happens. Are we transparent with society? Are we able to explain our decisions? So obviously, this framework links with responsible artificial intelligence, and it goes beyond, because in order to be, to have ethical values, to apply fairness, well, we need to, in other words, being able to explain how our algorithms make decisions. And the last part, depending on the market that you are, I don't know where you are, guys. Now I'm living in Malaysia, but I've been living in the past in Australia, in UK, in Spain, in France. So what happens, like the countries and the regions, they have specific regulations. Some markets are ultra regulated and they protect a lot the customer. Some other markets are more flexible. So the legal aspects will be extremely relevant. So you need someone in your company that's an expert in the particular, regulation that affects your industry, your vertical, and even what you're doing. We speak obviously with customer data. So to finish, have 7 recommendations. First, fairness is complex. Maybe you were not aware that it was a problem, but it could be a problem, and it could affect the revenue stream, it could affect your brand, or it could affect, your customers or your users. Second, removing the variables that you believe that is going to generate the problem, you are not removing the problem. The problem could be encoded in other behaviors, in other elements, in the results of the algorithm. So it doesn't make sense. Third, think about the notion of fairness that applies to the project, because that notion of fairness, it will affect which are the measures, the metrics that you use to understand what is happening. Invite domain experts and stakeholders to participate when you're developing the project. This is when we make the confusion, we make the mistake to think AI is all about technology. Technology is relevant, but it's about transforming our business, transforming how we operate. And then, there is not a unique metric. So we need to use several of them because they will let us to understand, okay, in my case, this is not a problem, but the other metrics are telling me there is something off. And it could be that this could generate risk because at the end, what we try to do is to reduce the risk in our organization. There are a lot of tools. I just introduced Equitas. Equitas is not only this incredible, summary, but it's a Python library that you can use. No, even in the website they have, you can upload your data and see what happens. No, just to check if you have issues. And the last but not least, and very important, remember, if we start tweaking the data, because we want to be fair, we apply all these potential mitigation techniques. You need to remember, we are going to reduce our performance. The same that happens when we are betting on security and we want to anonymize data or many other aspects. We are going to have less, performance in our algorithms. But having said that, I strongly recommend to start thinking about how to become not only a data-driven organization, but a responsible data-driven organization. Thank you so much. And if you have any questions, it will be a pleasure to answer them.
Thank you so much, Joseph, for this insightful session about fairness in AI. Really enjoyed the entire session, and I believe the participants share the same opinion too. So now we move on to the Q&A session. For the participants, if you're in here, feel free to use the question box on the right-hand side of the page. Just type your questions there, and then I'll moderate the question, and we have Joseph to answer some of those questions. Okay? So we do have one question from one of the attendees. Let me project that question first.
Excellent.
All right. I think this is a good question. Personally, do you see a lot of companies or profit-driven organizations view AI inequality as an issue that they need to fix?
Extremely good question. And let me share with you a little bit what I'm seeing now, not only in this market, but in many other markets, because I'm happy to say that I have this more open and worldwide view. So what I can see is like regulation is the first factor that is pushing companies to be more aware about the issues of artificial intelligence.
Yeah.
Because until right now, what was happening? We were just focused on, are we able to do it? Are we able to build it? Are we able to create the answers for the questions that we have? Are we able to implement supervised learning and unsupervised learning and all these techniques? And they are able to help the company to operate in a different way. So we have discovered that if we spend a lot of time and we build techniques and we collect the data and we create these amazing scalable platforms, we can do it. But once we put them into production, what happens is like we have seen these huge, ripples in the market. Like for example, with the Russian interference into American elections. No, I was living in UK during the Brexit. No, then I saw how some governments are using these algorithms to classify if it makes sense to give freedom to someone else. And not only in Spain, for example, I'm from Catalonia, and we have there, they have implemented a similar system, and they don't want to open the system. They are afraid to show similar results to Compass. No, so I'm seeing that in many places it's the pressure of the regulator, the ones that is forcing the companies to start thinking about which are our principles, what we want to do. And some of my customers is very interesting, no? Because they tell me, I already written my principles, and I want you to help me to create a roadmap to become a responsible AI-driven company. And then I start reading the principles, and there is one of them is like, we will use our algorithms to maximize the profit of our stakeholders. And it's like, I think that you don't get it. You don't get it yet. No, this is not about maximizing the profit, because your algorithms, most of the times, they will work worse. When you start trying to be fair, well, you need to rethink the approach. And the approach is not only about being fair or being ethical. It is about sustainability. One thing that is not discussed, and it's starting to be discussed, but it's not discussed enough, is the impact in the climate change of these algorithms. We have right now the foundational models from Google, Facebook, and many others that take months to train, that they use billions of parameters. And then suddenly they need a lot of consumption, a lot of power to be trained and to be used. So there is something wrong here. There is another trend that I invite you to pursue that is called tiny ML. Like it's the other way around. Instead of going to this massive, incredible systems, going like what we can do with the with these chips 2G, 4G that we know the Internet of Things, what we can do there to reduce the amount of energy that we need. There is a very amazing example is like in construction. They want to understand, if the structure is like here, landslides in Malaysia. I live here, it's raining and we have floods. So sometimes landslides. So one thing that you can do, you add some sensors within the walls. And these sensors, they will record the structural consistency of the wall, but they don't have energy. So that means that they are not producing any data until you go there, you measure, you provide external energy, and then they give you the information that you need. So that means that we can rethink the way we work. But that means that, well, it's thinking, it's a lot of effort. And having common sense of, that we need to work in a different way, not just on an individual basis, but as a company, as an institution, as a government, everyone, it makes a lot of effort. And I think that we are not ready for that. I have seen that during the pandemic that I was expecting more collaboration, and there has been collaboration up to a certain point.
I see. Okay. Thank you so much for the answer, Joseph. Let me check if we have any other questions. We don't have any question in the box now. Any last minute question? No? Okay, then we will prepare for the next session. So let me take some time to thank Joseph. Thank you so much, Joseph, for joining this event. Really appreciate it. And I hope to see you again one day in maybe our 2023 Big Data event.
It will be a pleasure. I'm always happy to share my knowledge, share my experience, and being able to, to try to help companies to not only use technology, but use technology in a responsible way. Yeah. We have the duty as managers to think not only for ourselves, to think for the next generations. I don't know, guys, if you have children, but I don't want to leave my daughter, a world that is worse than it is right now. No. So if that's the purpose, every one of us has a responsibility. And I think in the context of big data, analytics, artificial intelligence, and all these technologies, we have a strong voice, and we can help with that.
Yep.
Thank you so much, Jeremy, and thank you so much, the organization, to invite me to the event. And maybe next year it will be a pleasure to participate again.
Yep. Thank you, Joseph. See you again.
See you.
So for the rest of the participants, just to share, we do have upcoming 2 sessions that will be running concurrently. Let me share my screen and just to share with you one of the sessions. Okay. So for the next session, we have John, who is the head of data analytics practice from Source Group. So he'll be talking about data strategy and where to start. And the session that will be running concurrently is from Paul Comer, who is a senior technical trainer from AWS. So he'll be talking about introduction and demo of machine learning using Amazon SageMaker. So feel free to just go through the sessions that we have and just select the session that you would like to join. Okay, so I'll see you in a few minutes. Thank you and bye-bye.